Good morning, ladies and gentlemen. I am an engineer in Water Supplies Department. Today, I would like to share with you our experience in using BIM in the project on improvement of water supplies to Shuangshui and Fanling. BIM technology has been adopted in building projects in Hong Kong for decades, but its application in infrastructure projects has only started very recently. Water Supplies Department adopted BIM in the design stage for all waterworks projects since 2014. We have also issued the standards for BIM in our drawing office and for asset management in 2015 for internal use. Now this is the covers of the standard. If you are a BIM consultant and are interested in leading the jobs of WSD, please follow this standard in updating the SBU models. Okay, let's get back to the pilot project itself. This is our first project that using BIM in our design stage. The lack of reference projects with similar engineering nature and the adoption of BIM workflow has presented huge challenges to our in-house staff. Nevertheless, we have cleared the hurdles one by one. We have gained valuable experience in adopting BIM workflow and resolving problems specific to our project and have realized the benefits of migrating to this new technology. The scope of our proposed work comprises the construction of Table Hill No. 2 freshwater surface reservoir of capacity 24,000 meter cube, together with auxiliary structures and associated earthworks, pipework, drainage, and roadworks. And we will also lay about 3.3 kilometers of water mains of diameters ranging from 100 millimeter to 800 millimeters. This is the layout plan of our project. And the proposed surface reservoir is highlighted in green in the sketch. And the water mains are in red. And this is our existing surface reservoir. We hope to use BIM in the life cycle of the project from planning, design, construction, and maintenance. We have set up a workflow for the BIM. I'm not going to go into the details. Instead of engaging a BIM consultant, we have a project team on our own for this in-house project. We engage 4 technical staff to build the BIM model by ourselves. The software we use is Vivid for the surface reservoir model and Civil 3D for water mains and utility models. Now this video shows the general terrain of our BIM model. We use the topographical data provided by the Lands Department for building this model. And the proposed reservoir is at the middle of the video. Okay. The next video I would like to show is the fly-through of a section of proposed water mains, which will be laid underneath Mtong River to minimize the visual impact. We have included all details in the model. As you can see, we have included this pipe fittings of the water mains and also the ladders inside the chambers. All the dimensions of the pipes and fittings are based on the information provided by the manufacturers. Okay. This video shows a section of hot water main which will be laid as exposed pipes. And this is our proposed surface reservoir. We have designed the surface reservoir in such a way that it can bend in the environment. We will build green roof and plant trees to surround the surface reservoir. The walls of the surface reservoir will also be green. And then we have a section of buried water main coming out from the surface reservoir. And then go down a pipe trough. And another section of exposed water mains. As you can see, some of water main will be purple in color because at the end of the day, our freshwater supply system will be converted into a reclaimed water system. This video shows some section of water main lay underneath main cam road and jockey cup road, which are traffic sensitive. We have included all existing utilities, such as cables and drainage in the model to perform clash analysis detection. In the design of this project, we have used civil 3D to build BIM models for the existing utilities, including water mains. We have developed a Visual Basic program in civil 3D for automatic extraction and conversion of our existing water main data from our GIS system for building the BIM model. This is our GIS system. And we have all data inside this system for, say, the material diameter of the water main, so and so. Now we select a portion of our water main from GIS. And then we convert it into the data in our civil 3D. So that is. All the 2D data are now converted into 3D data. And you can see part of the 3D model of the existing water mains. Okay. The next video I would like to show is the our surface reservoir model in Revit. We try to include every details, such as the nameplate of the reservoir, hand railings, pipe works, manholes, subsoil drains, and even the manhole covers. By using Revit, we can view the model from any angles easily. We can also cut any section of the surface reservoir for preparation of 2D drawings. In fact, all of our tender drawings are prepared by using this 3D model. And we can collaborate with other professions by using the same model. Okay. The next video I would like to show is the process of how to build our water main model by using Civil 3D. First of all, we draw the alignment of the water main and then generate the longitudinal profile of the water main, the natural terrain. This is the natural terrain along the water main. Whenever we change the alignment of our water main, the profile will be updated automatically. And after that, we proceed to build the 3D model of the proposed water main based on this alignment. We define the proposed water main as pressure network in the model. And we should define existing utilities, such as the existing water main as solid rather than a pressure network. Otherwise, the speed of the software will decrease. After we build the water mains model, we can change the longitudinal profile easily by drag and drop the pipe bands. The information in the profile will be updated automatically in response to the change. So in fact, this process saves us a lot of time because in old days we have to do a lot of updated framework due to change in alignment if we use 2D from AutoCAD. We can also view the exposed pipe together with the terrain for assessing the visual impact. After determining the longitudinal profile and alignment, we can proceed to add the pipe fittings in the model. This video demonstrates how we use Civil 3D to carry out option evaluation for different shapes and location of our proposed surface reservoir. By using the software, we can determine the slope profile of the excavation easily. The slope profile in response to any changes in shape and location of the proposed surface reservoir can be reflected immediately. And the volume of excavation can also be determined quickly. All these powerful functions have saved us a lot of time in option evaluation and optimization. Benefits. We find that from migrating from 2D to more reliable 3D design, it helps us to identify clashes not easily visualized in 2D environment. Also, we can easily present the advantage of our proposed option over alternatives. The parametric model of the proposed surface reservoir enables rapid evaluation of different options. The automatic updating of the 2D drawings for any changes in 3D model saves us a lot of time. Errors or crashes can be easily identified while the 3D visualization in Civil 3D, InfoWorks, and Vivid, thereby saving the time idle in case of design changes and the time wasted for abortive works or reworks during the construction stage. 3D stimulation of project presentation enables prompt achievement of consents from the public. It also enable effective communication and collaboration of various stakeholders and expedite problem solving. The automatic regeneration of longitudinal profiles and updates of chainage for any change in alignment of water mains can be achieved by using Civil 3D. However, apart from those benefits, we have to face with challenges. This project has been selected as the first in-house project using BIM. Considerable time is required for solving teething problems, such as familiarization of the software and overcoming the deficiency of the Civil 3D. In general, more time should be allowed for building the BIM model, which is more complex than preparing 2D drawings. We have set up a small team of 4 technical officers to build the BIM model for the pilot project. Apart from attending training courses and seeking technical support from Autodesk, we have also self-learned by searching solutions from the internet whenever problems are encountered. Through the joint effort of our team, we have successfully completed the BIM model and just invited tender for the project last month. We hope that we can use this model to help the construction stage of the project. We have specified in the contract documents that the contractor shall employ a BIM consultant for preparing as-built records for our management of the completed assets. The contractor can also use the BIM model to plan their construction works. We will encourage the contractor and the BIM team to extend their innovations in areas such as construction methods, sequence, safety, staff training, and various assessment while stimulation in BIM during the construction. This project has also won the Small Projects Award under the Infrastructure category of AEC Excellence Awards 2016. Our project shows that a small and simple project can also adopt BIM technology to yield benefits despite limited resources. I believe that all infrastructure projects in Hong Kong should give it a try and enjoy the benefits. For WSD, we are now applying this new technology to more complex projects such as water treatment works. Thank you.